listening to the Decarbonisation Dialogue, a podcast from Salix.
Welcome to the Decarbonisation Dialogue. I am Hannah Walker, and I believe that the best way to communicate a message is by being passionate about what you are talking about. With me today, I have Mohammed Khan and Professor David Fay. They are both Chief Executive Officer and founder of Immaterial, which develops advanced material engineering solutions primarily centred on metal organic frameworks for applications such as carbon capture, hydrogen storage and gas separation. As CEO, Mohammed has transformed a range of businesses from energy, chemicals, water and other industrial markets. For more than 27 years, he has worked on technology, commercialisation, creating enterprise value and building partnerships. He has operated in most industrial geographies across the world. David leads the development of the fundamental technology, and he is also Royal Society University Research Fellow and Reader in Molecular Engineering in the Department of Chemical Engineering at the University of Cambridge, where he leads the Absorption and Advanced Material Laboratory. Now, that's quite a lot today, and I've got two fantastic guests, and I'm really looking forward to learning more about Immaterial, which is all, I believe, about carbon capture and hydrogen storage. And I will emphasize at this point that I am not an engineer and I'm not a scientist, and many of our listeners are not either. So I'm hoping that we'll be able to put a lot of this into a very simple language for all of us. But let's start by asking you, actually, both Mohammed and David, about your backgrounds. Is this where you imagined you would be? Let's start with Mohammed, because you're the CEO and founder.
Thank you, Hannah. Thank you for having us on the podcast. Pleasure to be here. Inspiration, I think, is from a number of directions. I'm an engineer by background, so I wanted to build things, and that's essentially how my career has evolved. It's been building, taking on enormous challenges, and creating something that's of significance and value to society and industry and customers at large. So that's really where I draw my inspiration. I guess the other aspect is working alongside very talented individuals and creating the sum of the parts, which is greater than the individual parts, and really seeing people shine is also something I draw deep satisfaction from.
And David, how about you?
I'm a scientist. I'm a chemist. I started working in the Department of Chemical Engineering in Cambridge. The motivation has been always about how we can really create new ideas. Scientist, I'm curious about finding new materials, new approaches, new solutions to existing problems. And having the opportunity to really jump from an academic publication where a few people will read it and will understand what we are doing into a real company where we have real translational work, where we can really have an impact, we can improve the quality of life of the humanity, of all the people. That's quite important, okay? And that was the decision, first of all, to really jump into Immaterial as a company. And as Mohammed said, all this is thanks to very bright people working around this technology, more than just one idea from the lab.
So let's talk about Immaterial for a moment, this company that you've founded. What big climate problem, and we're talking all about climate today, is Immaterial trying to solve? And how do your different roles, science and business, work together to tackle it? And I'm going to take that to Mohammed, please.
Our primary focus, obviously, is in decarbonising industry, and that's essentially helping industry capture carbon economically and cost effectively. So we're really tackling two challenges. One is the environmental challenge, where the temperature of the Earth, the planet, is actually rising, and therefore developing these solutions will enable a slowdown or a stoppage of that temperature, but it's bringing economically viable solutions to the marketplace that will enable that to be delivered. And secondly, with that environmental challenge around the climate, is solving the financial puzzle. It is an enormous financial puzzle, because in order to address the climate problems and deliver solutions, we need economically viable solutions that are actually affordable, that can be easily scaled and can be easily rolled out. And that's really where the business at Immaterial is focused. So it's very much looking at how we can actually bring to bear our technology, how that can be developed, expanded, tailored to deliver a solution that not only just creates a climatic solution, but actually enables a mass rollout. And that's really where we're focused.
And of course, recently, I believe that you raised, and do correct me if I'm wrong, you raised about, I think it was 18.2 million scale-up funding to move
US
this
dollars,
forward.
yeah.
US dollars to move this forward. And that is for specifically work across the US, is it, and Europe on this?
The European market, including the UK, and obviously the US market is where we are primarily focused. And this is about rolling out our pilots so we can do the technology demonstrations at scale and provide confidence around the solution to industry so we can then scale and then roll this technology out.
Mm-hmm. Okay. Because cost is something we talk about very often in our decarbonisation dialogue, of course, because there is a race, as you mentioned, to get to our challenging net zero targets and goals and to meet the various goals that we've been set. But of course, there is a cost to that. So the science, and I'm going to go to David on this, which areas like carbon capture from the air, and if you can explain this really simply for me, storing clean energy or helping industries reduce emissions, do you see as the most important for your technology? How does that all come together? Can you explain what it is, first of all, and how it works together?
So we are really talking about programs related with gas. It could be gas storage or gas separation. When we are burning fossil fuels, when we started burning fossil fuels in the 18th century with the Industrial Revolution, obviously we had a huge impact into the environment. It wasn't clear for a century or so, but obviously people started realizing that the greenhouse effect is a reality, climate change, and we see every year how the situation is more and more important, dramatic here. So the opportunity is really being able to really say, well, obviously we want to move into renewable energy, but this will need some time, some transition. So while we are still using fossil fuels, can we have a solution where we can really capture this CO2 that is produced in the chimneys? Okay, so we avoid all these emissions into the environment, and at the same time, while we are moving into this electrification of the whole industry, we will have also an opportunity in the future of continue using CO2, okay, but now with a value added. This is about carbon capture. Energy storage is also quite important because there is the opportunity of also densifying these gases and being able to really put higher amount of gas in a smaller volume, okay, which is always going to be important for any industrial application. Both solutions, even carbon capture or the densification of these gases, at the end of the day, we are using porous materials, okay, materials with a high pore volume, high porosity, to be able to interact with these gases, being able to capture the CO2 selectively, or being able to absorb and store hydrogen. The same with water, a lot of different applications. And the solution we are working, and this is the common point around all these different technologies, is around a new family, relatively new family of materials called metal organic frameworks. These are porous coordination polymers that received the Nobel Prize in chemistry this year. Okay, we were extremely happy to see this recognition, and it really makes very interesting technology, very interesting materials that we can use to, as I said, very selectively interact with molecules, gases, so we can really filter them, capture them, or store them.
Mm-hmm. That's interesting that you mentioned the Nobel Prize in chemistry, because that was quite a big deal, wasn't it? To have, and correct me if I'm wrong, but to have the fact that metal organic frameworks were recognised within that. What difference? How do you think that's been received? What difference do you think that's making to your work and to the communication of it?
So obviously, these technologies are very well known in academic environments, little by little in industry, but it's more difficult to really communicate this to your family, for example, to your friends and the public in general. Okay, being able to really understand the work we are doing is going to be quite important now. Thanks to the Nobel Prize, people will be able to recognize. It's a little bit similar to graphene. Okay, many people knew about graphene because it got the Nobel Prize. People were always looking for applications and trying to see how we can really use this new material, new technology. Okay, we have the opportunity now with these metal organic frameworks, because finally they were more or less discovered between 30, 25 years ago. They were finally recognized. That was super important.
Just going back to Mohammed, we talk a lot about technology and innovation when we talk about climate change solutions. We talk a lot about what we're doing to kind of mitigate the impacts that we see in our news practically every day. By the way, we're seeing climate change in our news every day. We talk about solar. We talk about heat pumps. We talk about heat networks. We talk about geothermal, for example. Do you think that people are talking enough about carbon capture, hydrogen storage, all of that? And what part does that play in the conversation?
I think it plays quite a central part, in the sense that if we looked at some statistics and looked at what are the largest sources of emissions, they're generally from industry, and that's where the topic is very central and extremely relevant. I guess some of the other examples that you cited affect consumers as well, and therefore they are more familiar with the terminology around solar panels and heat pumps and things like that. But what's really driving all of this is essentially three things. One, the temperatures are rising and the weather's changing, and people can see that, and that's quite visible, and that's obviously associated with the climate challenges and issues. Secondly, energy costs are rising. Wherever there is supply disruption, cost of living and inflation is affected. And if we look at the last sort of year and a half, 2 years in the UK in particular, costs of electricity and gas have been rising because of those supply disruptions as well. And then obviously, thirdly, is in order to have a new solution that is more environmentally friendly, addresses some of the scarcity hiccups, and is affordable, is where some of these technologies come in. And I think it's going to be a combination of a number of technologies across a range of industries and sort of value chains that will have the overall impact. But carbon capture or CO2 emissions is a big theme. It's a big issue, and clearly needs to be addressed in the right sort of economic manner, because that will actually help industry to roll it out. It needs to have a business case. It needs to have a payback, and also to alleviate some of the burden of government subsidies, for example, because obviously there are market cycles. Things go up and they come down. Funding isn't always available. So it's coming up with solutions that can stand alone, don't actually require significant subsidy, and can be scaled and rolled out because they are very affordable. People are very familiar with the engineering solutions, and they can be adapted very quickly. And I think it's a combination of all of those things that we really need in order to move the agenda forward. And that's really where we're focused as Immaterials.
Because we've talked about the cost, and you've raised money, and that's a challenge. And then, of course, and you've just mentioned scaling up of materials, which is another big challenge. Do you think that's the hardest part of turning the metal organic frameworks, or MOFs? I try and avoid acronyms in this, so I'm going to say the whole thing out in full. But what is the hardest part of turning metal organic frameworks into mass-produced, cost-effective products? What's the challenge that you're facing?
I think if we just dial back out and just look at what it is that we're trying to do, it's actually delivering a solution that makes financial and economic sense for the customer. The materials are one component of it, but it's actually delivering them inside a system. The greatest challenge is the demonstration. It's time. This is deep tech. We are engaged with a range of industries where our customers are primarily blue chip, so they are listed companies. So they want to see proof points at various capacities. So it's the timeline and the duration around that. I think for Immaterial, where we are focused and where we are very different is that we have a combination. So our innovation is obviously the materials and our ability to capture significantly more volume compared to other MOFs. There's a very clear distinction there. And then there is familiarity. So it's using unit operations, designs, systems that are familiar to industry. And so what we are doing is we've got a combination of where innovation is unique around the science. So it's the densification of our materials and how we actually do the integration inside existing proven at scale systems. So for us, it's a very different pathway. So it's combining innovation with familiarity, but the real focus is how do we do that in a very fast way so that we can actually have an alternative to the incumbent technology, which is a chemical process, which is extremely expensive.
And communicate it to those potential customers that you have. Now, David, can I come to you for the looking at we're talking about carbon capture, hydrogen storage, but we're also talking about climate change and greenhouse gases, and we want to obviously reduce the amount of carbon in the atmosphere. How do you ensure that through these processes that you're actually going to reduce the carbon and we're not actually going to create more through that whole manufacturing process that you're creating? You've launched a new company, there's a lot of people, there are more new products. How do we kind of make sure that it is fair and well balanced and achieving what you want it to?
The science that is done in the lab, obviously, is always difficult to scale up. It's difficult to really translate to industry. And this is why it's key to have this transition exercise where we make sure that we can manufacture these materials cheaply, in terms of energy consumption. We don't want to use very intense processes, high temperatures. We don't want to use toxic solvents, for example. We want to have some what we call green synthesis, which essentially means that we don't want to use high temperatures, high pressures. We don't want to use anything that is not almost water as a solvent, if we can. Really making sure that the manufacturing is relatively simple and it's never going to be exotic process that will be super expensive. Expensive at the end of the day translates into use a huge amount of energy many times, and that's what we are really avoiding. So we have seen this. We have seen that we can manufacture these materials without many difficulties. Now we have a material that will be able to really capture the CO2. Once we are able to really prove that the technology can be scaled up with the prototypes and the systems are working the way we say, then obviously that will make the big difference. And
of course, you're scaling up and you're doing all of that work. But let's talk for a moment, Mohammed, about government policies. What is it that we need to happen for a company like yours to make a difference?
It's a couple of things. If we look at the UK, for example, as a starter, we're the European trading scheme. We've got good pricing, market pricing kind of mechanisms being established. Where we need government policy to kind of focus is acceleration of new technology that is economically viable, because that will actually have a significant impact, not only in addressing the climate goals in the UK, but actually on the economy as a whole, because we would be avoiding significant amounts of capital. So if we look at the UK market, and let's say we decarbonised half of the UK market, we could probably add, in terms of capital avoidance, we would save at least 1/3 of the UK GDP. That's significant. And I think that's really where we need some bold moves to enable acceleration, not development, but acceleration of technology that's got promise that would actually help address the financial puzzle, because that will actually unlock economic growth and reduce significantly the burden on the UK economy as well, especially from a taxpayer, from a government perspective.
Mm-hmm. Let's fast forward 5 years. What does success look like for you there and your work, but the planet as well, Mohammed?
I think success for the company is about having a engineering solution that's ready for commercial rollout in very simple terms. And success for the planet is, I think, for us, speaking on behalf of everyone in Immaterial, I think it's deep gratification that we will have had an impact in bringing a new technology that is very affordable, that can actually secure a green future for future generations.
Because you have obviously set up this company. I think you're based at Cambridge Science Park, and presumably you employ people just as passionate as yourselves, looking at the generations ahead as well, looking to the future.
Absolutely.
David, in terms of the technologies, what possibilities or new possibilities do you see for the technology that could make a big difference in the fight against climate change?
I mean, obviously, the first one is all these around carbon capture. That's the closest market, the easiest way of deploying this technology to really make this difference, this impact that Mohammed was referring. But then, I mean, sky's the future. Sky's the limit. We can work on water harvesting Okay, we can work on reducing the impact of air conditioning, air heating systems by making systems which are much more effective, consume lower amount of energy. There is different gas separations, for example, that could be extremely expensive. And again, using these porous materials to selectively separate, discriminate between molecules will also have a huge impact. So a lot of different possibilities, a lot of different technologies, areas where these materials can be applied to.
Mm-hmm. Sky's the limit, indeed. My final question to both of you, I think I kind of know the answer, particularly after that sky is the limit comment. Question to Mohammed, are you positive or negative about our climate future?
Extremely positive, which is why we're obviously purposefully putting the effort in. We believe we can make a fundamental difference. So we're actually working backwards. We've looked at the industries, the market, the challenge, and ultimately every technology solution needs to make financial sense. So that really has been our starting point, and we're working backwards. And we've got a great combination of talent that's young, that's very energetic and very creative, along with people that have been there, done that a number of times or so many times. So we've got a very unique combination, and we've got a very pragmatic approach. And we believe we will make a significant difference. And we're really excited about that.
And it is super to have that combination, isn't it? So the set of people from all backgrounds and all experiences. Same question to you, David. I suppose it's negative or positive, or optimist or pessimist. I think I know what's coming.
Yeah, absolutely. I'm always a very optimistic person. I think climate change has a solution, but obviously it requires the effort of everyone as a society. We have the responsibility of really making these changes and making sure that we really pay attention to these problems. If we do this, then absolutely very, very optimistic. And this is where Immaterial can really offer this solution. Okay, carbon capture at low cost, low price is going to be very valuable.
Thank you very much for that very inspirational podcast interview. And that's a big thank you to Mohammed and to David from Immaterial and for providing such insight today. There can be no doubt that climate change is the biggest challenge of our time. Today, we must reduce greenhouse gas emissions to slow global warming. Today, we must act for tomorrow, adjusting our lifestyles to current and future impacts of climate change. Today, we must use our collective wisdom to deliver on our climate commitments. Today, we must work for tomorrow's world. Don't forget to subscribe to our podcast channels, and please do email us at podcast@salixfinance.co.uk with your ideas and even suggestions for our guests. Thank you once again to Mohammed and David.
Thank you, Hannah.
Thank you, Hannah.
You've been listening to the Decarbonisation Dialogue, a podcast from Salix. For more information about our work and to find more content, please visit salixfinance.co.uk/podcasts.